My dear students, how are you? I hope all are quite well. Today we are going to start the method of preparation of alkyl halides. Those students who have not watched my video of SN2, SN1, even E2, please go and watch. I taught in very detailed way so that now you will understand perfectly. My name is Ritesh Misra. Let's understand to the method of preparation of alkyl halides. Student, first we are going to understand from the halogen acids. So please you write that. First we understand method of preparations, method of preparation of alkyl halides. Alkyl halides, right? Okay. First we are going to understand from halogen, from the halogen acids. Students, see, we write the simply halogen acid is HX. Okay. Now students, see the HX can follow the SN2 path as well as SN1 path. 2. Why I am saying you the HX will follow the SN2 and SN1 path both. First I write here something. See that 1 degree, simply 1 degree alcohol will follow SN2 path. How? See students. ROH you have, and we have taken the HX. H will attack because of long pair is there. So what will happen? That ROH and H is there, correct? And X will attack from this side. So that what happened? That will form the RX plus water. So this state is SN2 state. But what happens if our alkyl halide is 2 degree or 3 degree? Then it will follow the SN1 path. So we can say that such HX will follow either the SN2 path or SN1 path. It depends on the structure of alkyl group. So let's understand. See here, we have that this alcohol here is 2 degree alcohol. What happened? When we take the HX, it will follow the SN1 path. So through the SN1 path, what will happen? That compound will form like, okay. Similarly, one more example we understand here, students. See here is a OH and here is a carbon. So what happened? Again, since it will follow the SN1 path and here is the probability of to form the carbocations. So what happened? It will form the carbocations CH and here C H cations and C. So hydride will sit here. Cation will form here, as you know. So what will happen? The compound like that X and H2 and H3 will form. Correct? So the HX can follow the SN2 or SN1 path. It totally depends on the structure of alkyl. Done? Okay. Students, so what we can say in the HX, what about the alkyl alcohols? Since it will follow the SN1 path, usually it follows the SN1 path. So the alkyl halide order is halide, then the 3 degree, then the 2 degree. Correct? Then since it will follow the SN1, usually it follows the SN1 path, so we go the halide, 3 degree and 2 degree. Now as far as concerned about the HX, students, you know I have already taught in the first or second video of the living group, better living group and good nucleophile. The students, if we talk about the HX will follow the HI, then the HBr, then the HCl, and then the HF. Usually, HF will not involve in the reaction. Why HI? Because I is better living groups, correct? As well as a good nucleophile also. I have taught you, so please, if you have a confusion, you go and watch the video. So HI is a better living group as well as the good nucleophiles, and HBr then the HCl. So now we talked about, sir, what will happen when the alcohol react with HI? See, students. One by one we understand the reaction rate. What happened when the HI will react? What happened when the Ki will react? What happened when the HBr will react? What happened when the KBr will react? Similarly, Sc. See. Now, what I am telling you that see the reactions how it will happen. See, students. Now we talk about when the ROH. Okay, ROH. If you have HI, it will directly react. Almost 57% you have to take the HI, and alcohol you have to take as a reflex of alcohol. Reflex of alcohol means alcohol accelerate the reactions with respect to the evaporations. That is called reflex. So simply you can say that alcohol react with HI directly, and that will form the alkyl iodide plus water. But students, the HI will take the excess 57% seron, and the alcohols is reflexed alcohol. Reflexed alcohol means that alcohols will take accelerate the alcohols with respect to the evaporations like that. So alcohol react with HI, then the form alkyl iodide plus water. Now the question is, sir, if we take that HI, that simply will form, correct? But as you know, that usually when the halogen acid we take with the alcohols, we take the dehydrating agent. When, see that, when ROH students, we take the HX, correct? We always use the dehydrating agent. Dehydrating agent. Dehydrating agent. Dehydrating agent means what agent we will take? Like the anhydrous zinc chloride or conc H2S, who remove the water from the molecules, and then the alkyl iodide is formed, alkyl halides or whatever alkyl halides will form. So what I am telling you, when we take the ROH HI directly alkyl iodide is formed because it is highly reactive. So what I am telling you, either you can take the 2 or 3 alcohol, despite being HI can react faster as compared to HCl or HBr, because already I told you the iodine is a good living group, right? Now what I am telling you, so since HX react with the SN1 part usually, so what we can say, the rate of reaction is directly proportional to stability of intermediate carbocations. What? Stability of intermediate carbocations, correct? Stability of intermediate carbocations. Now what I am telling you, what will happen, this is NCERT questions, your index NCERT question is that, what will happen when we take the H2SO4 with the hydrogen iodide or with the potassium iodide. Suppose we have to take the potassium iodide. Is it possible to take the H2SO4 as a dehydrating agent? See what will happen. Why we are not using the H2SO4 with the potassium iodide? See, one thing understand, alcohol directly can convert into alkyl iodide with the HI. But another way we can prepare that alkyl iodide with the potassium iodide. But the question is here, sir, is it possible to take the H2SO4? No, students. H2SO4 is oxidizing agents. So we have to take the non-oxidizing agent like H3PO4. Why we are taking the H3PO4 as non-oxidizing agent? So we understand through the reaction. See. So what happened? Why we are not taking the H2SO4? See, student, alcohol we have taken, which will react with the, if I take the, suppose potassium iodide and H2SO4, see what happens. Still H2SO4 is a what? Oxidizing agent, which oxidize potassium iodide, 2 moles of potassium iodide plus H2SO4 and form the 2 moles of HI plus K2HSO4. Why it's happened? Because of H2SO4. Because H2SO4 is a good oxidizing agent. Now next step again, what happened? HI again. HI react with the H2SO4 and form, what happened? Just you see that I2 plus SO2 plus H2. So instead of alkyl iodide, what happened? Iodide is, here is I2 will form. Correct? So therefore, we always avoid to take the H2SO4. Instead of H2SO4, we will take the H3PO4. that will directly convert, and heat will supply alkyl iodide. Clear? So alkyl iodide you can prepare directly with the HO. 57%, 58% you will take that and directly you can form the alkyl iodide. Correct? Now the question is, same process we will use for alkyl bromide also. The less percentage of the alkyl bromide we will take, potassium bromide, less percentage we will take. But the same process we will use in streams. Now the question is, sir, what about the alkyl chloride? What about the alkyl chlorides? See students, is it possible that at normal conditions the reaction is possible? No students. Suppose I am asking you, see, what I am asking you, that is that possible like the alkyl iodide? Is that possible like the alkyl iodide? What you have seen, that alkyl iodide, alkyl alcohol react with the HI and directly alkyl iodide is formed. Correct? So is that possible with the alkyl chloride? No. Students, see that when alkyl alcohol HCl intake at normal condition, that reaction is not possible because halogens HCl is a very slow reaction, give a very slow reaction with the alcohols, because I have already taught you the iodine is better leaving groups, and you can say that that is the and iodine is also good nucleophiles. So that is the regions that iodine directly give the reactions, but HCl not at all. We need a dehydrating agent like H2SO4 or anhydrous zinc chloride. What they use, they will initiate, they will propagate, they will help to remove the OH as a living group. See, understand what will happen when we take the anhydrous zinc chloride, then reaction is possible, then alkyl chloride is formed. Correct? So, and as you know, the mixture of, you can see that mixture of HCl and anhydrous zinc chloride, 1:1 mixture, right? That is called Lucas reagents. So this is called Lucas reagents. So student, what happened? Why we take the anhydrous zinc chloride? Because the zinc chloride is a dehydrating agent. But what is the process actually that follow the SM1 path? But we understand the logic that how it will happen. See, strings are OH we have, which have a long pair of electrons. You know, zinc chloride is a dehydrating agent as well as zinc is a d block element, which are vacant d orbitals, right? So you can say that which act as an acid also. So for zinc chloride that will accept the electrons from the long pair from the oxygens, right? So as you know, all the d block elements which are vacant d orbitals, which accept the electrons, which act as a base acid, so that will take the electrons, okay? And since oxygen has given the electrons, so what happened? It will form the ROH zinc chloride. Since oxygen has given the electrons, so contains positive charge, it contains a negative charge. Okay? Now see here, what happened? If it is a 3 degree alcohol, 3 degree strength, so obviously it will be 3 degree or 2 degree because SN1 path is there. So what happened? That will remove here because it is unstable. So now what will happen? That will form like that R cations plus Zn OH Cl. Now since we have taken the HCl, so what is the use of HCl strings? H plus and Cl negative. Now Cl negative will attack on this alkyl group, and that is a liberated alkyl chloride. So remember, this alkyl is a 3 degree or 2 degree, right? And H plus combined with the OH, H plus combined with the OH and form the water plus zinc chloride. Okay? So I hope you understood what is the use of zinc chloride to remove the water. So here water is removed, correct now? So anhydrous zinc chloride or contrast always enhance to remove the water molecules. Now the question is, see, understand through the example of this alkyl halides. See, I take one example. See, suppose we have taken here 3 degree or 2 degree alkyl halide. So suppose here, students, right, we are taking here C2H5, C, CH3, H and OH. Correct? Okay. Now I am telling you, when we take the anhydrous HCl plus anhydrous zinc chloride. See what happens in the two cases happen. As you know, because it is chiral center, so what happened in two cases? One is C2H5, C, CH3, Cl and H uniform. This is called retention. It is called retention. Okay, and second case is if there is mirror image going here. So what happened? If you put the mirror image, so what happened? Cl, C, CH3, H and C2H5. Retention, this is the inversion. Correct. So any compound which have retention inversion, that is the optically inactive. So that is this compound is OI. Understood or not? So that is the process of in the Lucas reagent. These things will happen. Correct. And now what I am telling you in the Lucas reagent is usually if we take the 1 degree alcohols. Suppose we are taking the 1 degree alcohol. 1 degree alcohol students in the Lucas reagents with Lucas reagents. So what happened? That will give the alkyl halide, but at least 30 to 60 minutes. 30 to 60 minutes, and after heating it will give 30 to 60 minutes alkyl halides. 1 degree alcohol, when we take the Lucas reagent, that will form alkyl iodide within the 30 to 60 minutes. And if you take the 2 degree alcohols with the Lucas reagents, that will form the alkyl halide, that will form the turbidity. So within the 10 to 15 minutes or 5 to 10 minutes. And 3 degree alcohols, when we take the Lucas reagent, that will form the alkyl halide, means turbidity in the few seconds. A few minutes, that will form the turbidity in the few seconds or few minutes. That will form the turbidity. So this is the use of the Lucas reagent. So Lucas reagent always involved in the SN1 path. Always follow the SN1 paths. Correct? But keep in mind, 1 degree alcohol if you have, that will follow the SN2 paths. Right? Now I am telling you one more thing, students. If you have a alcohol, 1 degree alcohol or 2 degree alcohols, and HCl as a gas, 1 degree, what I am telling you, see here. If you have a 1 degree alcohol, see students, if you have a 1 degree or 2 degree, usually 1 degree, I am telling you 1 degree or 2 degree alcohols, that will react with HCl as a gas, and you have taken the anhydrous zinc chloride, that will form the alkyl halide. Correct? This is called Group's process. What is called? This is called Group's process, students. So Group's process always follow SN2 path. Keep in mind, Group's process follow the SN2 path, students. 3 degree alcohols without anhydrous zinc chloride directly will form the alkyl halides. Right? So 1 degree, 2 degree, usually Group's process follow the SN2 paths. Now what I am telling you, that if you have 3 degree alcohols like that compounds, COH and HCl which we have taken, directly we form the directly we form the alkyl halides. Right? I hope you understood all these things. How the anhydrous zinc chloride act, why the H2SO4 will not use the directly with the to formation of the alkyl iodides. Okay, so thank you so much. Next we will go with that Darzen's process, anhydrous zinc chlorides. Okay, thank you.